Have you ever gazed upon the night sky and wondered how the distant stars live their celestial lives? For centuries, humans have been captivated by these twinkling points of light, often attributing them to divine beings, lovers, lost, or signs of prophecy. But what if I told you that stars have lives too, albeit vastly different from our own? In this cosmic journey, we will explore the fascinating world of stars, from their fiery birth to their often dramatic demise. And in particular, we will focus on one specific stage of a star's life cycle, the white dwarf phase. This is the stage where stars, much like our own sun, spend the majority of their twilight years. So, strap in, stargazers. We're about to embark on a journey like no other, traversing the universe from the comfort of our screens. Today, we delve into the cosmic cradle-to-grave journey of stars, specifically their transformation into white dwarfs. To comprehend the transformation of a star into a white dwarf, one must first understand the life cycle of a star. Every star begins its life as a mere wisp of gas and dust in a nebula. These nebulae are vast cosmic nurseries where the interplay of gravity and pressure sparks the birth of a star. The gas and dust begin to collapse under their own gravitational pull, forming a dense, hot core known as a protostar. As the protostar continues to accumulate mass, its temperature and pressure rise dramatically, setting the stage for the next phase of stellar evolution. When the temperature at the core reaches a scorching 10 million degrees Kelvin, a process known as nuclear fusion begins. Hydrogen atoms collide and merge to form helium, releasing vast amounts of energy in the process. This energy, in the form of light and heat, is what makes a star shine. Now the star enters its longest and most stable phase, the main sequence. A star like our Sun can remain in the main sequence for about 10 billion years, gleaming steadily as it converts hydrogen into helium. The balance between the inward pull of gravity and the outward pressure from nuclear fusion keeps the star stable during this phase, but of course nothing lasts forever. Once the star exhausts its hydrogen fuel, it begins to fuse helium and other heavier elements in its core. This signals the beginning of the end. The star expands, cools, and changes color, becoming a red giant or a supergiant. However, not all stars share the same fate. Their destiny is determined by their mass. Stars with a mass similar to our Sun become white dwarfs, while more massive stars end their lives in dramatic supernova explosions, leaving behind neutron stars or black holes. As we now understand, a star's life is a cosmic dance of nuclear reactions. But what happens when the music fades? The death of a star is as spectacular as its life, if not more so. As we venture into the demise of these celestial bodies, we find ourselves in the midst of a cosmic spectacle, a dance of energy and matter that is both fascinating and awe-inspiring. Just like any living being, stars too have a lifespan, a period of birth, maturity, and eventual death. The death of a star is not marked by a sudden cessation, but rather a gradual, spectacular transformation. This transformation is triggered when the star exhausts its nuclear fuel, the very energy that keeps it shining bright. Imagine a car running out of fuel. It doesn't stop abruptly. Instead, it splutters, coughs, and gradually slows down. Similarly, a star doesn't go out with a whimper, but undergoes a significant expansion, becoming what we call a red giant. This stellar giant is an impressive sight, its diameter reaching over 100 times that of the original star. It's like watching a small mountain grow into a colossal peak right before our eyes. The red giant phase is a sign that the star is in its twilight years. The nuclear reactions within its core have slowed, causing the star to cool and expand. It's a bit like an old wise being, its energy spent, growing larger and more peaceful with time. But don't be fooled. This peaceful giant is still a powerhouse of cosmic energy. As it expands, it sheds its outer layers, releasing a torrent of gas and dust out into the cosmos. This stellar wind is a sight to behold, creating beautiful nebulae that are the nurseries for future stars. This process is not an end, but rather a transformation. The core of the star, now exposed, begins to contract under its own gravity. The once fiery and vibrant center now becomes a dense hot core, the heart of a new entity. Thus the stage is set for the birth of a white dwarf, a stellar remnant that has run out of nuclear fuel. Once a star has exhausted its nuclear fuel, it enters the white dwarf phase, a cosmic metamorphosis of sorts. This is not a process that happens overnight. It is a gradual yet dramatic transformation that takes place over billions of years, much like a caterpillar transforming into a butterfly, but on a cosmic scale. Our star begins this journey by shedding its outer layers in a series of explosive events known as nova eruptions. This shedding is not a sign of decay, but rather a star's way of preparing for its next stage in life. It's an act of cosmic rebirth, if you will. These outer layers are cast off into space, creating a spectacular celestial display known as a planetary nebula. Meanwhile, the core of the star, having lost its nuclear fuel, begins to contract under its own gravity. This contraction is not a gentle squeeze, but rather a fierce compression. The core, once a fiery furnace of nuclear fusion, now becomes a dense, hot ball of matter. As the star's core contracts, the pressure and temperature rise dramatically, causing the core to glow white-hot. This is the birth of a white dwarf. This white dwarf is no ordinary celestial object. It's extremely dense, so much so that a teaspoon of white dwarf material would weigh as much as an elephant on Earth. Despite its small size, a white dwarf packs quite a punch. Its surface temperature can reach up to 100,000 degrees Celsius, making it one of the hottest objects in the universe. But a white dwarf is not a star in the traditional sense. It no longer has the nuclear furnace that once powered it. Instead, it shines because it's hot, and it stays hot because of its incredible density. It's a new kind of celestial object, a testament to the star's past life and a beacon for its future evolution. And so, the star we once knew is no more, replaced by a dense, hot white dwarf. It's a profound transformation, a testament to the incredible, dynamic life of stars. Even in death, stars continue to awe and inspire us with their cosmic metamorphoses. The journey of a star doesn't end with its transformation into a white dwarf. Quite the contrary, this celestial phenomenon merely enters the next chapter of its cosmic journey, a chapter that unfolds over billions of years. Now, imagine a cooling ember in the aftermath of a roaring fire. This is the white dwarf, a dense, hot core of a star left behind after it has exhausted its nuclear fuel and shed its outer layers. As time passes, this ember, the white dwarf, cools and fades. It's a slow process, mind you, taking billions of years. And during this time, the white dwarf continues to shine, but now it's a ghostly glow, fueled by the residual heat of its once fiery existence. But what happens when this residual heat finally dissipates? Well, our white dwarf undergoes yet another transformation. It becomes a black dwarf, a theoretical stellar remnant, as no black dwarf exists in our universe yet, simply because the universe isn't old enough. The transformation from a white dwarf to a black dwarf is an exceedingly slow process, taking longer than the current age of the universe. A black dwarf, in theory, is a cold, dark, and inert mass. It no longer emits heat or light. It's the final resting state of a star. It's a celestial tombstone, if you will, marking the end of a star's long, luminous journey across the cosmos. Now, one might wonder, does a star's journey have any impact on the universe at large? The answer is a resounding yes. Stars in their death contribute to the cosmic cycle of birth, death, and rebirth. The elements that they produce during their lifespan and their explosive deaths enrich the interstellar medium, seeding the universe with the ingredients for new stars, planets, and potentially life. Thus concludes our exploration of the life cycle of stars and their transformation into white dwarfs. But remember, every end is just a new beginning in the grand tapestry of the cosmos. In this cosmic journey, we've witnessed the birth, life, and death of stars. We've seen how these celestial bodies ignite from clouds of dust and gas, living out their days by fusing hydrogen into helium. We've watched as they exhaust their fuel, swelling into red giants before shedding their outer layers into beautiful planetary nebulae. We've observed the core, now devoid of nuclear fuel, contract under the force of gravity to form a white dwarf. This celestial remnant, about the size of Earth but with the mass of the Sun, is a testament to the star's former glory. It gradually cools and dims over billions of years, living out its twilight years as a faint ember in the vast cosmic fireplace. In the grand tapestry of the universe, the life cycle of stars is but a single thread, woven into a much larger narrative. As we gaze upon the stars, let us remember that each one has a tale to tell, a tale of cosmic birth, life, and death.